Okay, so here we are for day 4 of our Algebra 1 Spring Semester Final Review. All right, we're going to start here with question 25, which says, the graph represents the relationship between the height of a ball and the distance it traveled after the ball was thrown. And so we have that lovely graph right there, and we want to check it out. It says, what conclusion can be drawn from the graph about this relationship? So I think we should probably read the conclusions and compare them to the graph. Okay, so this first one, the ball reached a maximum height of about 16 feet after traveling a horizontal distance of approximately 33 feet. Wow, I've got a little ghost in my machine. Okay, so maximum height, this would be the maximum height here, which seems to be about 12, not 16, and that happened at right around 14, not 33. So A doesn't work. The ball was thrown from a height of approximately 7 feet above the ground. Okay, let's see, we're counting by 2. So 2, 4, 6. That looks like 6. I guess an argument could be made for 7, but it'd be a hard argument to do. Let's see about the rest of it. And traveled a horizontal distance of approximately 10 yards before it reached its maximum. Well, the 10 is over here. The maximum is over here, so that's definitely out. It's not 10 yards. Okay, let's see what else we got. The ball was thrown from a height of approximately 6 feet above the ground and traveled approximately 20 yards before it reached its maximum height. Let's see. So it does look like about 6 feet, but again, it only traveled 14, not 20. So it's not C either. Let's check out answer choice D. The ball reached a maximum height of about 13 feet. Okay, we could make an argument for 13. My line wasn't quite straight, so 13 being about there. Okay, and then approximately 14 yards, which is what we said, between 12 and 16. So D matches both parts, so we would select D. Okay, the graph shows the relationship between a 1-ton car's kinetic energy K and its velocity V. Right, so let's come on down and see what that relationship is. Okay, if the kinetic energy of the car is proportional to the square of its velocity. Okay, now if the relationships are proportional, that's our old friend y equals kx. Okay, and in this case, it's proportional to the square of its velocity, so that would be y equals kx squared, which makes it a quadratic equation. So this is going to continue. This graph would continue on, right, kind of doing that thing. All right, and it says then if the kinetic energy of the car is proportional to the square of its velocity, then its kinetic energy when traveling at 60 miles per hour is about what? Okay, so since we were able to extend that, we come up here from 60, and I can see, let's see, we're counting by 50 here, right? 50, 150, 250, 300. All right, so we're counting by 50. So if I'm coming up this line, that's around 650. So let's see what our choices are. All right, we don't have a 650. 720 is probably the closest that we have. Something we could do if we wanted to be very, very precise with this, because I could make an argument for 720 if the way I drew my line, right, it could come a little bit more this way, which would put us a little closer to 720. So, but I could also find the precise answer because I could figure out what this K value would be because I know points along the way. 0, 0 is not particularly helpful, but right here we have what appears to be 4,300. So if I put 300 in for Y and 40 in for X, then I would have K would equal 300 divided by 40 squared, which is about 2. And if I wasn't sure about that one, I could pick another point along the way, like here, I'm estimating, but it's about 3,200, and I tried that point and everything. I get a number. I tried several points off camera, and so you'll just have to take my word for it. But I tried several points along the way, and they all come out pretty close to 2. So with that being in mind, I could put y equals 2x squared in my calculator and actually go and find the exact value for 60 if I so desired. But I think for this one, just sketching it out, most of you would have agreed with our answer there of H. Okay. All right, 27, the area of an isosceles right triangle. Okay, so if you don't remember, right triangles have a right angle. Isosceles means 2 of the sides are equal to each other. Okay, is described by this equation, where x is the height in centimeters of the triangle. What is the height of the triangle? So really, doesn't really matter that it's a triangle. All they're really asking us to do here is figure out what x is, because x is the height. What is the height? Okay, so if x squared equals 576, then x equals the square root, right, of both. And we do the plus minus usually, right? But because it's a right triangle, it's only going to be the positive answer here. Okay, so I would probably just pop this into my calculator and figure out what the answer is. So to find it out, I'm going to take the square root, so control x squared of 576. I get 24, which is choice B. Easy peasy. All right, moving on. 28. The polynomial x squared plus 6x plus 5 is modeled below. What are the solutions to this equation? All right, we've done similar problems. If you want to use the key here, basically the algebra tiles are telling you that this would be x, and then 1, 2, 3, 4, 5, so x plus 5. And then this side would be x plus 1, and those would be the factors. Okay, so if you want to go with factoring method for solving this, the tiles would be very helpful. Most of us, however, remember that when we are looking for solutions, we have our Inspire calculators, and we just do menu 3, 3, 1. Degree is 2 because that was our highest exponent, and we're looking for real roots. So we just put in the coefficients, which would be 1, 6, and 5. All right, so there's our expression, and the roots are -5 and -1. All right, cool beans, let's move on. Okay. A student threw a ball upward from the ground. The table shows the relationship between the elapsed and the ball's height above the ground. I think that should be elapsed time. Let's write that in there. Okay, so if the height of the ball is a quadratic function, so quadratic, remember, gives us that shape, parabolic shape. So if something happens here, it's the same height, or in this case it'd be height. The height of the ball would be the same in 2 different locations. So usually we look to see if, unless it's the vertex, right, it's the maximum point, then it's going to happen twice. Okay, so 3 feet. Well, let's see. They already showed me going up to 3.9 here, so I know, and since there's a repeat between these two numbers, somewhere in here is where my vertex is, right? My vertex would be in there, but they didn't ask about the vertex. They said, what's happening at 3 feet? Well, here's 2, here's 3.4375, so somewhere in here, between 3 and 5, is going to be 3. And then again here between 11 and 13. So let's see, what's between 3 and 5? 4. And what's between 11 and 13? That would be 12. So I think our answer choice here would be A. Okay. All right. Let's see. We'll be moving on to 30. The graph of the function y equals x squared plus 2x minus 8 is shown below. What are the y-intercepts and x-intercepts of the function? Okay, it's pretty easy when they give you a lovely graph like this. Here's an x-intercept, here's an x-intercept because we're on the x-axis. So the x-intercepts would be negative 4, 0, and 2, 0. Okay, and then the y-intercept, here's our y-axis. Our y-intercept is down here at negative 8, so the y-intercept would be 0, negative 8. Give me some more of those, please. That was too easy. All right, 31, what are the solutions to this equation? Use the quadratic formula. All right, so since they said to use the quadratic formula, I will, but more easily we could use our n-solver on the calculator. Not n-solver, our polynomial tool that we recently used, but we're going to use the quadratic formula, which says that x is equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. Okay. Where a comes from the coefficient of x squared, b is the coefficient of x, and c is the constant. So if we fill this out, that would be negative 9 plus or minus the square root 9 squared minus 4 times 1 times 12, all divided by 2 times 1. Okay, so here what I would do is I would put this in my calculator. 9 squared minus 4 times 1 times 12 and I get 33. Okay. So that means that negative 9 plus or minus the square root of 33 divided by 2 is the value for our x. Okay, this 33, square root of 33 is not going to be a whole number, and the 33 is the product of 3 and 11, which means there's not a perfect square in there, so that is its simplified form. So this is my final answer using the quadratic equation. If you use the polynomial tool, it would give you a decimal, and if this was being a multiple choice test, you would need to convert this answer into a decimal as well in order to compare them. Okay. All right, 32. And I think that's our last one for this section. Let me double check on that. Yep, it sure is. So 32 is our last one. Yay! What are the solutions to this equation? Use the quadratic formula. Okay, so same deal. X is equal to the opposite of 2 plus or minus the square root of b squared minus 4 times 3 times negative 5 all over 2 times 3. Okay, again, I would put this in my calculator. So we'd have 2 squared minus 4 times 3 times negative 5, and we get 64, and if I take the square root of 64, I get 8. So my answer now is negative 2 plus or minus 8 over 6, which means I want to break that apart to negative 2 plus 8 divided by 6 and negative 2 minus 8 divided by 6, which this becomes 1 And this would be reduced to negative 5/3. Okay. And so that is my answer, 1 and negative 5/3. All right, we'll see you on video for day 5. Bye-bye.